Hey everybody, thank you for clicking on my video. I really appreciate it. If you haven't subscribed, please consider doing so. So for those that are new, what I do is I take old electronic magazine projects and I bring them to life. I build them right from scratch, put them in a case and test them. That's what I do. Hopefully that interests you. So for those that think I'm a genius, I'm far from that. I'm just a technician at the very most. So if you have any really complex questions, I'm probably not going to be able to answer them. Maybe this isn't the right channel. Who knows? However, the good thing is there's a lot of people that do know the answers, and I get a lot of comments with regards to the function of the actual circuit, and that's how I learn. So it's a great learning experience having this channel on YouTube. It helps me in understanding a lot of these projects. So what we're going to do today is we're going to take an old electronic project from Popular Electronics, October 1971. Gosh, that's 54 years ago, I think. And it's a 30-watt amplifier. It's called the Plastic Tiger Audio Power Amp, 30 watts. And the reason they call it plastic is because the actual output transistors, I suppose back then, were plastic. Mine, I think, have the metal backing, but whatever. That's why they call it the Plastic Tiger amp. There is a cousin. If you go back to, I think it's December of 1970, there's the Universal Tiger amp, and that's like 80 watts. Who knows? Maybe we'll get to that one day. So I'm showing you the author's version right now, and it's pretty Spartan up front, which is great. The less rotary switches and potentiometers, the better. And I'm showing you the inside now of the author's version. You'll notice that there is 2 channels. I'm only going to be able to build 1 channel because I only have the parts for 1 channel. But maybe what I'll do is I'll leave some space for a 2nd channel should I have to come back, and if I get the parts, I can put a 2nd channel in. So let's move on to the schematic. All right, so just a high-level overview. The Plastic Tiger amplifier, 30 watts at 8 ohms. It's a Class AB amplifier, and the highlight is it has protection on the outputs from an open or dead short. Now, I can see there's a fuse at the output at the far right. If you look there, there's a 2-amp fuse, so I suspect that's for dead shorts. Not too sure where the protection comes from, the an open condition, but I'm sure somebody could actually probably comment on that. So just quickly go through the theory. I know I don't want to spend a lot of time only because my videos are very long, but again, I'm not smart. I just got this information, what I'm about to tell you, from the actual article, okay? So if we look at Q1 and Q2, that's a differential amp, and the signal will go to the base of Q1, and Q2 base gets the feedback from the output. So if you look down the center line there, our output right from that inductor goes right back to Q2 and the base. And Q9 provides us a current source, and it's what do they say? It provides controlled emitter current. So that's got to be good, right? Q1 drives Q3 on the positive half. Q4 is the negative half. And Q3 and Q4 will drive Q5 and Q6. And that apparently that gives us a gain of 2. And I think there's the gain is set by 2 resistors according to the article. Yeah, so for Q5 it's R15 and R12. And for Q6, it's R16 and R14. What else can I say? Oh, the diode 2 and diode 3, plus the potentiometer, is where we get our bias control, right? So I suppose we're going to have to do a set. We'll have to set the bias. And in the article, they ask for the diode 1, diode 2 to be transistors. So I know they're a little bit more, well, so you can get big diodes too. But anyway, I'm not too sure exactly why they want us to do that. But I'm just going to follow the directions and continue on. And Q7 and Q8, of course, are our finals, which gives us the 30 watts. So let's get on with the build. I'll show you the parts and we'll build the board, etc. All right, so I've gathered all the parts, as you can see, and I am actually waiting for a couple of transistors, but I've got most of them, and I've got a great transformer. I think this came from some consumer electronic device, VCR or something, who knows. Anyway, it's 45 volts center tap which is exactly what the schematic requires. So that's fantastic. And by the way, the power supply will be external. So I'll be using terminal tie strips and stuff like that, right? And there's the board. It's a little bit bigger. So as you can see, there's the actual printout. So I'm using the Staples glossy paper this time. I get pretty good results with that. The blue paper is much better, but I'm going to try with the glossy paper. We'll see what happens with the outcome. And for those that are wondering how I cut my boards, well, I use these old shears, and I'm sure you can get modern ones, but these things work great. Now, there is a limit, of course, too, right, on the thickness of the board. But this is pretty average thickness. I don't know what it is. It might be 0.8, could be 1 millimeter thick. I'm not too sure. But I get through it, no problem with these shears. So the next step is for me to actually put the transfer onto the board and through the laminator. And once that's done, I'm going to put it in the etchant and I'll etch the board. And I'll bring it back in at that point. So for those that are new to my channel, this is the laminator that I use. So I put the actual pattern on top of the board, and then I put both of them through this laminator. And I'll show you my fume hood too for the etching. Okay, mind the noise, sorry about that. So this is the fume hood, and it's homemade, just out of some thin backer panel wood, I think is what you call it. And I've got the 2 computer fans actually going outside into the window. Anyway, that's my fume hood. Okay, just one quick step here also that I wanted to show you. So the board and the transfer paper were put through the laminator, and what I do is I just put them in a small container. It's just water, warm water, and then I start to peel the paper off. Now the glossy paper, it sticks really, really well. So it looks like it's going to come off like in one pull. Unfortunately, this paper takes a little bit of effort where you have to use your thumb, the skin on your thumb, and kind of gently peel the remainder off. Anyway, that's the process. And yeah, I'll put the board in the tank very shortly. All right, so the board is etched, as you can see. There's a little bit of a hanger-ons around here. Not too sure what's going on there, but that's fine. It's not touching. These traces are very big, so I'm not too concerned. I did have one part. Maybe I didn't leave it in there long enough, but that part was connected to that trace. I just kind of scratched it out. All right, so let me drill the holes in this thing, and then I'll put the components on. I'll do a time lapse, and I'll bring it back. Okay, so for those that are following along at home, which I highly doubt, R19 is a 10 ohm resistor, and what you have to do is you have to wind 8 to 10 turns of number 26 wire around it. All right, let's continue on. All right, so as you can see, I've got channel 1, the only channel, because I don't have a transistor for channel 2. I've got it done. The article expressly advises the person building the project to, cut certain lengths of wire, like, 2, well, how about these 3 right here? Where are they? Right there. Those are 10-inch wires. And I know point H is the input, right? And I also noticed on the actual photo inside the article of their version, the inside, they're not using shielded cables. But I think for now, what I'll do is I'll just keep them as regular hookup wire, and we'll test it out. And in the end, obviously, we'll be using shielded cable for the inputs and the outputs probably. Yeah, so I think at this point, I'm almost ready to test it. I have to put a heat sink though on the bottom. So I think I showed you that I'm using, this is the way they wanted it too, by the way. And even with this transistor here, by the way, it's acting as a diode for the biasing. So they want that diode, the bias diode, close to the actual transistor. This is the output, right? 2N39 or 2N or MJE 3055 and 29995 or 2955. So I think they wanted close because of temperature compensation, etc. It's going to be pretty tough to get that mounted onto the chassis of the metal case, but I'll do my best. So I think at this point I am ready to test it out after I get a heat sink on, and I need a power supply plus and minus 40 volts. So I don't have a lab supply that'll do that. I'm going to go ahead and build the power supply in the chassis, the one they recommend, right? It's a very simple power supply. So I think I'm going to get the chassis and build it in there, and then that'll be my power supply, and I can test this board off on the bench. Anyway, I'll bring you back in as I progress with the power supply. So I thought I'd just bring you back in just for a minute, just to show you the progress on the power supply and actually the board itself, right? So the board's going to fit in there. But you can see I'm using one of my homemade cases, and yeah, I've got a big transformer, and I'm just putting the AC cord in yet right now, so I've still got some work to do. And the output will go to the bridge rectifier, as you can see. And then, yeah, from the bridge rectifier, I'll go to those two caps. So the schematic for the power supply is very simple. There we go. That's better. So that's the power supply. Nothing fancy. Anyway, so let me continue on with this, and I'll bring you back in shortly. All right, so I've got the power supply completed, as you can see, and it works. So I've got a nice heat sink on the back, just in case. And the front panel looks like that. So I still got to put the input. So the actual amplifier board will go on the left on the back, and all of the connectors will be in the front on the left also. So there's a picture of the power supply. Nothing fancy, point-to-point wiring, but it does the job. Let me tell you, those caps are pretty big. You can hear the clunk for, a second when you turn the power on. Anyway, that's what I had, so that's what I'm using. So again, 33.5 volts on each side, and we're good to go. So what I'm going to do is get the amplifier board ready, and I'm going to hook it up temporarily to this power supply and give it a go. All right, so I've got the power supply completed, as you can see, and it works. So I've got a nice heat sink on the back, just in case. And the front panel looks like that. So I still got to put the input. So the actual amplifier board will go on the left on the back, and all of the connectors will be in the front on the left also. So there's a picture of the power supply. Nothing fancy, point-to-point wiring, but it does the job. Let me tell you, those caps are pretty big. You can hear the clunk for, a second when you turn the power on. Anyway, that's what I had, so that's what I'm using. So again, 33.5 volts on each side, and we're good to go. So what I'm going to do is get the amplifier board ready, and I'm going to hook it up temporarily to this power supply and give it a go. Okay, so I'm not going to lie to you. I've been working on this for at least a day extra from the last video clip. And yeah, I went through 3 sets of the output transistors. So that's the 3055 and the 2955. I know. I'm not that smart. In any event, I learned a lot again from the troubleshooting. And the problem was, and I know you can't see it, but there's these transistors here, that one and that one there. And the way they describe, so you got to cut the center, it's a transistor, so, and we're going to use it as a diode. And the way they describe it, so you cut off the collector, which is in the middle. So you're left with 2 leads. Well, the way they did describe it in the article on how to hook those up was wrong. It was reversed. They said connect the emitter to this little dot on the actual board on the underside. Well, these are PNP. Those are PNP transistors. So it's actually the base that has to go on where that dot is. In any event, I reversed them, and now it works. I'm not blowing up any more outputs. So those are going to be extended out on wires. I had those wires on before. I think you've seen them maybe. And they'll go back, they'll run around to the back to go right beside the actual output transistors. So yeah, let me show you a quick test here. I'm going to have to put it on pause. I have to set it up. So I was hoping to get this video done. It's Thursday at 7:45. What I like to do is I like to get a video completed by Thursday night, upload it to YouTube, schedule it for tomorrow, Friday at 4 p.m. I don't think that's going to happen. It still might, but yeah, got a bit of a problem here. As you could see, there is a blown capacitor. It should look like that one there. Where am I? There. However, it looks like that. Now, I have some suspicion on the configuration that they told, well, I should say told, that they advised me in the actual overlay. I think clearly it's backwards. So I'm just going to switch it around, but it makes perfect sense when you actually look at the schematic compared to the actual top board layout. But I can't get that done in time. So let me see how I do. I've got a eye doctor's appointment on Friday, so I don't think I'll be able to get it all done. But you never know. You might see this on Friday, but if not, you'll see it on Saturday. Okay, so I've changed out the capacitor, and I double-checked the outputs or the finals, and they're fine. Thank goodness, because I didn't want to take that board off. So I just wanted to show you the construction first before I turn it on again and do some tests. So it's pretty Spartan up front. You know, we've got an input and an output, and then the on and off switch. It's that simple. The board is placed up against the back, and this is the inline fuse to the output. And this is our power supply unit here. So big old transformer. I think that came from an old VCR or something like that. But it's fantastic. It's perfect. Oh, and I measured the output voltage, and it's plus 33.5 and minus 33.5. So I read the article, and the actual schematic said it was going to be 40 and 40. However, when I read the actual details of the article, it did mention, you know, if you get anywhere between 30 and 35, you're fantastic. So we're good. Now, okay, I know. The heat or the heat sinks aren't the greatest, but that's all I had. I think it'll be okay. We'll run it really hot and see how it goes. And the output transistors, I think I mentioned this earlier, are attached, of course, to the chassis, right? So anyway, that's the configuration. So let me put it, I'll tell you what I'm going to do. I'm going to put the cover on. Should that capacitor go again, then at least I'll be protected. So anyway, let's do some testing. All right, so the setup is very simple for this test, and we're going to do a power test. So I've got the output of the amplifier connected to an 8 ohm dummy load, and we're looking at the scope right now. So let me just increase the input, and my scope probe won't even, or sorry, my scope won't even read it completely, but we are doing about 42.5 volts peak to peak. So that's quite a bit. Just break it down a little bit. So when I go to the calculator, there's an online audio amplifier power calculator. I could do it by hand too, but since it's there, why not? So input of 42.5 peak to peak with an 8 ohm dummy load, we get 28.22 watts. Okay, so that's actually pretty good. Seeing that it's advertised as a 30-watt amp. Usually you don't get that. Usually it's a lot lower. But anyway, I'm happy with this. All right, let's move on to the next test. Okay, so I'm going to just go through the frequency ranges. So my function generator has a low, medium, and high. So let me just go through those. And what we'll do is we'll look at the frequency response from a low frequency to a high frequency and see if the voltage goes crazy on us. Let me just increase the gain here. All right, that's pretty much full scale. So we're doing about 40 volts peak to peak. So I'm on the medium range right now. Let me go to the low range. So when you look at the levels, they're pretty much the same. And there's the high range. Okay, we lose a little bit at the top. Maybe not. Let me just adjust this. I know the knob on my Tektronix is broken, so I have to kind of dig in there. No, it's probably the same, right? And it looks good. Let me even go higher. Can I go higher? Yeah, that's the highest I can go. So, but yeah, it looks good. Looks really, really, really good. Nothing wrong with that. So this is, let me read what kind of frequency we got right now. Okay, so that's 13.8 kilohertz right there. And this is 1.32 kilohertz. And this is 140 hertz. So not bad. Actually, I could probably even go down more. Yeah, my frequency counter won't even measure it at this point. I know I should be showing the frequency counter, but production values aren't the greatest as usual. So yeah, anyway, it looks pretty good from low to high. All right, let's move on to something else. Another thing to mention is I don't see any crossover distortion. Now, of course, when I reach a certain peak, it's going to clip, right? And that's about it right there. And that's about that 42.5 volts peak to peak. But certainly does clip. In fact, it just my function generator is maxing out at that point anyway. All right, let's move on to something else. Okay, so as far as the tests go, I think that's all I'm going to do. Only because it's Friday at about 4:40 p.m. and I usually have my videos uploaded for 4 o'clock on a Friday, so I'm already late. So what I'd like to do is just play some music. Now, the speaker that I got, it's a pretty crappy one. It's 15 watts maximum, so I don't want to blow it. Although it doesn't really matter to me because it's a crappy speaker. But it is an 8 ohm speaker. I had some trouble trying to find an 8 ohm speaker. I've got a lot of 4 ohms. That came from an organ as usual. So yeah, I've got the amplifier here. And what I'm going to do is I'm going to play some music from my computer, which goes into my stereo, and the auxiliary jack will come back and feed the actual amplifier itself. So YouTube, this is YouTube music. It's good. All right, so let me just press the button on the computer here and I'll play, and then I'll swing you around to the scope. Oh, turn the power on. Stopped me on the street last night, said everything's alright. Roller coaster, make it through the day alright. It seems your meal ticket is gone, but life goes on. I could never imagine something better. Yeah, right. Now you're cooking on high heat in the middle of the street. Roller coaster, take me to a better time. You seem to easily forget how to place your bet. When everyday life gets you down, you gotta steal the crown. Got to own it. Don't bet your Now, how's that for a power supply? So did you see that? I turned the power off and it kept on playing for about 10 seconds or more. Awesome. I think they're like 10,000 or 12,000 microfarad capacitors on each side of the plus and minus 40. Anyway, so I think that's going to conclude this project. I had fun, and I had, you know, some rough spots when I was making this. Of course, I blew 3 sets of the finals. And, but you know what? I figured it out. And like I always say in the beginning, I'm not an expert, I'm not a genius, but I certainly do learn after I've got the circuit built, and I learned from troubleshooting and I found the problem. There was actually a couple problems, but whatever. I figured them out and I'm happy I did. All right, so we're going to move on to another project, and I'll just kind of give you a sneak peek. Sneak peek. Sneak peek. All right, we'll leave it at that. So it's almost done, but it's a complex project. So I'm, you know, it's gonna be a tough one. All right. So thank you for watching. I really, really appreciate it. And if you haven't checked out some of my other videos, please do. And bye for now.